In this video, I want to show you a fully analog timer and clock that I built. This circuit shows seconds, minutes, and hours, and it can work both as a clock and a timer. The counting itself is done using real electronics like the 555 timer and others, not software. The system is also connected to an Arduino microcontroller, but the Arduino is used only for control, not for counting. Before we go inside the circuit, let me first show you what it does. When I plug the system in, nothing happens. That's because the system starts turned off. To turn it on, I press the red on-off button on the remote. Now the display turns on, but you can see that nothing is counting yet. This is because the system always starts in a pause mode. To start the timer or clock, I press the unpause button. Now, the seconds start counting, followed by minutes and hours. At any moment, I can press pause to stop everything. Press unpause again to continue from the same time. Nothing resets unless I tell it to. If I press the 0 button on the control, the entire system resets. Seconds go to 0, minutes go to 0, and hours go to 0. If I want, I can start the timer again or shut it off. This makes it very useful as a timer. Just like the timer, it starts in off mode. So to turn it on, I press the red on-off button on my remote. But unlike the timer, where I want to start from 0, the clock I want to set. So if I press the up triangle button, the minutes increase by 5 minutes each press. If I press the down arrow button, the hours increase by 1 hour each press. All of these buttons are handled by the Arduino, but the control, timing, and counting are done using hardware logic. Now that you've seen what it does, let's explain how it works. To show numbers, we use a 7-segment LED display. A 7-segment display is made from 7 LEDs shaped like bars. Each segment has a name as shown in the picture. A is the top LED, B is the top right LED, and C is the bottom right LED. By turning on different segments, we can display numbers from 0 to 9. For example, to display the number 1, we turn on segments B and C. To display the number 5, we turn on the segments A, F, G, C, and D. Now each segment has its own pin. When that pin receives voltage, the segment lights up. The green lines in the picture show the pins connected to each segment. For example, if I give voltage to the top left pin, segment F turns on. The 4026 counter's job is to count from 0 to 9 and directly drive the 7-segment display. The 4026 counter has 16 pins, as shown in the picture. Every time it receives a clock pulse on pin 1, which is the top left pin, the number increases by 1. At the start, the number is 0, so segments A, B, C, D, E, F are on. After 1 clock pulse, it becomes 1, so only segments B and C are on. This continues until digit 9. When the counter reaches 9 and goes back to 0, it sends a pulse on pin 5 called the carry out pin. This carry out pulse is used to trigger the next digit's clock pin, increasing it by 1. For example, if the next digit is at 0, it will now climb to 1. If it is at 1, it will climb to 2. The 555 timer is the heart of the clock. This is what gives the pulse of 1 second. In our project, the 555 timer is wired in astable mode. Astable mode means it never stops by itself. It produces a continuous on-off pulse. Each pulse represents 1 second. To achieve this, in my circuit, I use a 4.7 unifarad capacitor, And then for the resistors, for resistor 1, I use 100 kilo ohms. And for resistor 2, I use 125 kilo ohms. And in addition, a 10 kilo ohm potentiometer in series with resistor 2. The potentiometer allows fine adjustments. Because the 555 timer is analog, it is not perfectly accurate. So I adjust the resistance, test it with a timer, sometimes let it run overnight, and then make small adjustments on the potentiometer until I get a 1 second a pulse. Before I explain how this circuit works in practice, I want to say that I learned how to use these components, the 555 timer, the 4026 clock, and a 7-segment display and much more from a book called Make Electronics by Charles Platt. Most of the diagrams and pictures used in this video come from this book. This is not an advertisement for the book, it's simply an excellent resource for learning electronics from the ground up. If you want to understand how these parts work in depth and not just a short video, I strongly recommend this book. Okay, so let's get into how the circuit actually works. So as mentioned, the 555 timer, which is this little guy over here, is the pulse and heart of the clock. It is connected in astable mode. Here's resistor 1, it's 100 kilo ohms. And then resistor 2 is all these guys over here. That's also connected to a potentiometer, which you could turn around and adjust for getting an exact 1 second pulse. Now, the pulse comes out on this yellow wire and goes to the clock of the 4026 timer. It goes to this pin, pin 1. Each time it goes from 0 to 1, or it goes from low to high, it triggers the timer to go up by 1. So you see 5, 6, 7, and so on. When the timer gets to 9, it automatically goes back to 0 and also sends a pulse on pin 5, which is this yellow guy over here, this yellow wire over here, and that we redirect to the pin 1 of the next segment. So right now that's the segment of the 3. When this gets to 9, it's going to send a pulse on the yellow wire and move this up 1 to 4. Now the problem is that unlike the first segment, which we wanted to go up to 9, because this is a seconds, we want it only to go up to 6, meaning 59 is the maximum. So how do we do that? Because this timer is built to go up to 9, not up to 6. So we're going to use here some logic, and we're going to use an AND gate. What we'll do with this AND gate is we'll funnel wires to the AND gate to see when segments A, F, G, and E are on. When they're on, we will get a positive or a true from the AND gate. And then that's this yellow wire over here. We will go and reset. Well, this will go to pin 15 if I'm not mistaken, which is the reset. It will reset this to 0, and it will also send, on this little diode over here, it will send a pulse to the minutes to go up by 1 as well. So again, this gets to 59, it resets this to 0, and also sends a pulse to the minutes to go up by 1. Now, on the minute side, it's very similar to what we saw on the second side, meaning this goes up to 9. After 9, this goes back to 0 and triggers in this. Actually, we'll see it soon because this is 54, 55. On the seconds, when this gets to 60, this will go to 20. Oh, exactly. As we see, this goes to 20. So this went back to 0, sent a pulse on this yellow wire to 1 to trigger this. Now, just like at the seconds, we don't want this to go up to 9. We want it to go only up to 60. So we use the same AND gate over here. We funnel in wires. We check to see if segments A, F, G, and E are on, which means it has to be a 6. In that case, we reset this by sending, see this resistor over here goes to pin 15. We reset it, and also we use this yellow wire to activate the hours. So again, it also goes to the timer, to pin 1, and activates the hours. Now, the hours is a little bit different because in hours, we don't want it to go up to 59. We only want it to go up to 24, as it's a 24-hour clock. So here we have to take funnel wires from both segments and logically check if it's 24. If it is 24, then you can see here on these two yellow wires, we reset these two segments to 0, this segment to 0, and this segment to 0, and now the clock is midnight, or 0000, and then it restarts again. Now, the 5-5 timer is a little bit problematic as it's an analog circuit. It's not completely accurate, meaning even if you do play around with it and put the right resistance and capacitance, it is still not completely accurate. I would recommend, if you want to hang this up as a timer or a clock, to buy maybe a 1-second oscillator. You can buy them for cheap online, and that way it will be much more accurate. Okay, let's see how the Arduino interacts with the timer and clock. So running everything is really the infrared remote and receiver. So as mentioned, when you plug it in, it is off, and to turn it on, you hit the red on-off button. Oh, that turned everything on. Well, how does that work? Well, this red wire over here, which is connected to pin 11 of the Arduino, is giving power to the whole power bus, which gives power to all the components. Now, when you plug it in, this is low, off. When you hit the on button, this gets power and lights everything up. Now, to shut it off, it goes low again and everything shuts off. So let's turn it on. Now, if we're using this in timer mode, we need to set the clock. So we said like this: if you hit the top triangle, it increases by 5 minutes every single press. The down triangle, the hours increase by 1 every press. Well, how does that work? Well, if you can see, we have here two strings, two wires that are connected to pin 1 of the low digit minute clock. When we want to increase 5 minutes each time, the code causes the pin to go high, low 5 times. That increases by 5 minutes, and it's controlled by the up triangle. When we want to increase an hour, the code causes the pin to go high, low 60 times, which keeps the minutes the same, but increases the hour by 1. Fantastic. Now, if we want to pause, right, then we hit the pause button, which pauses it. How does that work? Well, if you can see this little blue wire over here, which goes to pin 2 of the first clock, goes high. If it goes high, automatically it pauses the low second segment. But because it's a domino effect, that the low segment triggers the high segment, which triggers the low minute segment, which triggers the high minute segment in hours, if we pause the first, it pauses all. To unpause, we hit it again. Now the blue wire went low and everything continues as did before. Now, if we want to reset everything to 0, we hit the 0 button on the remote. As you can see, it went to 0. How did that work? Well, the black wire is connected to pin 15 of the timer. When that goes high, it resets this segment, the low second digit, to 0. But that's not enough. We want to reset everything to 0. So we connected here yellow wire that's connected to pin 2 of all of the counters. That's why when we hit the 0, it resets everything. To start again, we hit the unpause and it starts as before.